Okay, let's look at a few examples, general examples, just problem-solving type of questions based on polynomial functions. All right, so suppose we have this scenario. We want to come up with the equation of the polynomial function given a few set of information, and then also we want to sketch the graph. Now, sketching in the graph, we don't have to be very accurate, just to sketch it roughly, and then we can go and check on Desmos and then make sure that we are doing it okay. All right, so the first thing is that we're given zeros. So these zeros are given to us, -2, 2, and 2, and has a y-intercept of -16. Now, this is when you see this piece of information, especially when you see the number of zeros, you have to assume that that's the maximum number of zeros. So that is the cubic function. Okay, so that makes it a little bit easier to deal with, because you could come up with infinitely many different types of functions if that does not, if it's not assumed. Okay, so let's find out where they are. -2, so this is -2, so each of my partitions are -2 units, so that's -2, and that is 2, but then we have 3 of them, but we have only 2 in here. So, and then we also have -16 as y-intercept. Okay, so now we know if it's a cubic function, so that's a cubic function. Make a note. That's a cubic function, and based on the information that we have, we know that at 2, or at, let's be more very specific, at x equals to 2, the graph has a repeated or double zero, double roots. Okay, that means the graph touches at x equals to 2 but never crossing it. So if that's the case, I can't be the graph, the end behavior cannot be in quadrant 1 and quadrant 3 that usually the cubic function behave. So this is probably, and it is, flipped. So that means that our graph is going to come from the, I'm going to start it actually here as a dotted, so it hits the graph, sorry, it hits the x-intercept at 2, then it's going to bounce off. Now, we don't know how it's going to bounce off, but it's going to bounce off. And then the next piece of that is that it goes through -2. Okay, so it looks something like that, and it is just a sketch. It doesn't have to be perfect, but that's a sketch of it. All right, and so that is where we know. And here's another thing: do we know that it actually the minimum value is -16? We don't know. So it, in fact, if I want to make it a little bit more accurate than that, it could be going down more even. I have no idea, because we don't have enough information unless we plot a lot of points to figure out what that is. Okay, so now that we have that information, let's come up with the equation. The equation of this is, so we start with y. The piece that we don't know is the leading coefficient, but everything else we do know. We're going to put them in a factor form. So factor form of x when x equals to -2 would be x plus 2, and then x minus 2 squared. We know the coordinate 0, -16 is on the graph. Okay, and if we know that 0, -16 is on the graph, we can plug that number in and easily solve for a. Let's solve for a. So when we solve for a, we will get a equals -2. So I just substituted x, 0 for x, y is -16, plug it in there, solve for a, because we need to know the leading coefficient of this cubic function, and sure enough is negative. We already anticipated that. So now let's go ahead and double check with Desmos. Let's see if it's correct. So here is the graph and our prediction was correct. In fact, this minus 16 was not the lowest point for this part of the graph, so it actually crosses the y-intercept and then went back up, but here it is. So that's the point where the positive 2 was the value, the x-intercept, where we had a double zero and it bounces off of the x-axis. Great. Okay, very good. So let's look at the next question. Same idea. So let's go through it again. This time let's start up with the equation. Okay, and so the equation f of x equals, we're going to start with a because we don't know the leading coefficient in this case, but we know everything else. This 0 here, it actually represents just x. There's nothing added or subtracted. And then the next factor will be x minus 2 because of the root 2, and because of the root 4, the next one will be x minus 4. Great. We know that these are the zeros. We can go ahead and sketch the graph quickly, but before doing that, let's go ahead and solve a, or solve for a, given the fact that we have this coordinate 3, 9 on the graph. So we're just going to use, that's your x, 3 is x, 9 is y, plug it in there and solve for a, and then we can rewrite. So when you plug in x and y into the equation, you solve for a, and a end up being minus, so a is minus 3. Great. Now we can rewrite the equation as, so f of x now is minus 3 times x minus 2, x minus 4. Now you can go ahead and sketch this. Okay, and this is the sketch. We have the 0, 0 here. That is one of the zeros. X-intercept again. We got 0, 2, 4. They all pass through. We know it's negative. The end behavior is in quadrant 2 and quadrant 4. And that's a sketch. Is it exact? No, it is not exact because I don't know how far down this goes. And we actually don't know how far top it goes. It could have been that it passes the top as well, okay, but that's what we're gonna have for now until we use Desmos to make it exact. So let's do that. Okay, when you have the graph of the function, it looks like this. We were not 100% accurate, obviously, so that point here, it turned out to be a little bit higher, but in terms of the zeros, we got a 0, we got a 2, we got a 4, and then the part below this curvature right here is actually comes down almost to minus 10, which our original sketch didn't have that. But you get the point. The behavior, we got it correctly, and that's all that matters right now.